Takanori Kawashima from University of Tsukuba, and will chair this session. It is our honor to welcome Dr. Takanori Kawashima from National Diet Library, Japan, to the ICADL this year. He will talk about the design of Japan Search they developed, and I believe this topic is interesting to all of you because it is European-like system to aggregate a variety of contents in Japan. Dr. Takanori Kawashima is the lead engineer of Japan Search Development Team. He received a PhD from Tokyo Institute of Technology. And this talk will discuss the system design elements of Japan Search and why and how they reached their decisions. And we welcome many questions from the audience, so you can type your questions in the Q&A window, okay? So please welcome him with big hands, although we are online. And Dr. Kawashima, now the screen is yours.
Thank you for introduction. My name is Takanori Kawashima, and I work at the National Diet Library for almost 10 years. But today, it's a great honor to have this wonderful opportunity to give your presentation. And here at NDL, we are working on a national project called Japan Search, which is released on August this year. Today's presentation is about the system architecture of Japan Search, and I will do some demonstration of the functionality of the Japan Search. About myself, I'm working at National Diet Library for almost 10 years, and I'm primarily working for development of library systems, and also nowadays I'm working for digitization of books. Also, I've joined the R&D for Next Generation Systems Office in National Diet Library since 2012, where we study and develop digital library-related systems, which includes new search systems or OCR-related products. Japan Search is also developed in this office, and I'm lead architect and programmer of the system. My research domain is actually digital humanities. So my domain overlaps with digital library or digital archives, but my primary concern is about text analysis domains. So please note that I'm not an expert on metadata systems or such things. So I think my measure is reflected on the decision of Japan Search, because Japan Search has very loose metadata schemes. Okay, today's agenda is as shown on this slide. First, I'll explain overview of the Japan Search itself and the requirements and design principles, overall architecture, and detail of components. So start with overview of Japan Search projects. Japan Search links digital archives in variety of fields, organizes metadata of various content presented by Japanese organization, and enable users to one-stop search through various Japanese content, like Europeana in the EU and the DPLA in the United States. This includes publication of libraries, cultural assets, and works of museums, official documents, and also academic resources, for example, specimen photographies, like that, and also TV programs, films, and movies. It aims to promote the use of Japanese content by not only making metadata searchable, but also clarifying the secondary use condition of this content and promoting distribution of the aggregated metadata via APIs. Shown here, shown here is the top page of Japan Search. Please access these URLs. This is Japan Search linking model, which is similar to Europeana or DPLA models. The range of cooperation of Japan Search is not limited to specific field, and any organization that holds content such as social, cultural, and academic information resources can be partner for cooperation. This diagram shows how Japan Search aggregates and provides metadata in collaboration with institutions. Each content holders provide digital content and metadata to aggregators first, or aggregators of each field, such as books, cultural properties, or media arts, broadcasts, and so on. And Japan Search collaborates with those aggregators to collect metadata. The NDA, National Typed Library, is an aggregator of publications, books. So we collect metadata from databases of public and university libraries and provide the metadata to Japan Search through the portal site called NDL Search, which is, they are very similar names, but NDL Search is different systems, which only targets books. With aggregators, collaboration between Japan Search and holding institutions proceeds smoothly, and users can also obtain standardized data because aggregators make standardized data with their systems. However, at present, there are many sectors and communities that do not have aggregators. Actually, duty of aggregator is very heavy, so currently, our project has not so many incentives to aggregators, unfortunately. Therefore, in the cases that sectors or communities have no aggregator, we sometimes connect directly without no aggregators. I think this is a difference between Europeana or DPLA. As of December 2020, Japan Search collaborates with 24 aggregators and 115 databases and give access to about 21.8 million content. This shows thumbnails of databases which we connected. Okay, these are overview of the Japan Search projects. And hereafter, I'll explain system and technology aspects of Japan Search. First, to make computer systems, we must define requirements of the services. But as I joined this project, there are not so explicit requirements because there are a wide range of target users, local residents, businessmen, students, and so on. And also use cases very various. Project manager said users can reach contents they want to find, but it's very difficult to define what they want or how users want to utilize the contents they reached. So requirements are ambiguous from the start. Of course, very basic requirements such as metadata search functionality or content viewers are mandatory, but we did not know how to focus design intentions. Thus, I made very simple design principle to start. The first is flexibility. Japan Search is very flexible in its core, especially in metadata format, metadata search, and gallery functionality, which is essentially, gallery is is essentially content management system of some sort. The second principle is speed. Faster is always better. So we use single page application architecture for Japan search, and I implemented a lot of small techniques to speed up search and showing detailed pages. If you access Japan search and searching, of course, it's not lightning fast, but compared to many other digital library systems, it's very fast, I think. The third is rich API. As Japan search is single page application, many resources can be accessible through REST-JSON API, not only metadata, but also databases or organization informations. For example, these URLs, I'll copy the URLs to chat window. This upper URLs is a API search URL for the searching with Japanese long sort, and lower URL is a search result page for our website. Actually, they have similar URL queries in common because on the GUI web pages, we just use searching API, which is actually published in the website internet. And we just use this API and display the result on the screen. So Japanese core function of Japan search is also published as form of API. Also, we have separated Sparkle API, which expert users love. So this is core functionalities of Japan search. We collect data in many formats with very simple mapping. And also you can search these metadata in various ways. The most unique feature of Japan search is to create various search forms with GUIs. I'll demonstrate the functionality later. And to utilize data, you can use REST API or Sparkle API. And if you are a light user, you can create your own gallery on Japan search. So we have many type of utilized functionality, and I will explain them also later. And this is a primary difference between Japan search and European or DPLA. And as I said, largest difference is metadata model. Basically, this is because European and DPLA adopts mainly cultural heritage metadata. Japan search is not limited to cultural heritage, but also scientific data, for example, specimen of fishes or plants or something like that. And also we incorporate governmental data. So, and in this regards, metadata mapping is very different because European or DPLA has explicit mapping with European data models, which is very complicated to me, but where we are very loose mapping. I'll explain later, but we only need ID and title fields to mapping to incorporate data into Japan search. Also, compared to, because we have a variety of metadata formats, our search is very customizable. And I think European or DPLA has only European data model. So their search is not customizable as far as I know. Other difference is smaller, but Japan search has more functionalities compared to others because Japan search is the newest camera to this field. But note that European and DPLA has far more rich contents. mainly because Japan Search only covers Japanese institution only. So these are basic difference. And after that, I will explain overall system architecture of Japan Search. And this is system overview. We use AWS, Amazon Web Services as infrastructure, and uses Elastic Kubernetes services. Japan Search is implemented as Spring Boot Web Application Container and uses Elasticsearch as background search engine. Japan Search is heavily dependent on Elasticsearch, so most of data is stored in Elasticsearch. And I can say Japan Search is kind of very rich graphical user interface of Elasticsearch because our customizability utilizes the flexibility of Elasticsearch. Also, we use some other products like Baldo for vector search, which is used for image search, and also TensorFlow for machine learning, which is used to extract the image feature of the thumbnails. And as for RDF store, we use Virtuoso. And as for single page applications, I have chosen the Vue.js as a framework, and we use Webpack or TypeScript, and also as for III viewer, we adopt Leaflet and Leaflet III viewer. So these are technologies we used. So our application architecture, system architecture is not so special, but modern for at least, I think. And our system is working on Kubernetes, so our system is auto-scaling and also has auto-healing capability. And performance, we have optimized performance with single page application and with CDN. And also a continual integration and continuous development is implemented. So we have released 50 minor fixes in 3 months after the publication of the Japan Search. It is very easy to release with CI/CD once CI/CD is implemented. And also we use no relational databases. So most of data is stored in just Elasticsearch. This is a source of the quick responses, I think. Also, this is an overview of application layer. I can't explain in detail, but we have the following hierarchy. In Japan Search, there are many organizations and users, participated organizations users is type to one of them. Organization has databases, multiple databases, and databases include collecting, which is single upload or collection of file. These databases also has mapping and field definition of original databases. And after under the databases, we have actual metadata, which is stored on Elasticsearch. Also, organization can have galleries, which they can publish on Japan Search, and also organization can create their own custom searches. Well, as I said, organizations and databases and its setting, gallery, search mapping are all retrievable from API. Using these APIs, front-end application is implemented. So this is overview of Japan search architecture. And after that, I will explain details of components. And this chart shows what steps are to be taken after receiving metadata from aggregators or data providers in order to publish metadata via Japan search. There are mainly 3 steps: registering metadata and providing common properties and providing metadata as linked open data. In the first step, data providers or aggregators register metadata into Japan search in their original scheme. Metadata files can be registered in a variety of file formats, including XLSX or XML or JSONs, or even TSV or CSV. In the second step, the received metadata is automatically given common properties, such as title or URLs, and the common property enables the cross-search of the content. In the third step, metadata is converted to Japan search schema. JPS, which is JPS RDF schema, to be published as linked open data. Note that this third step is not taken immediately because once you providing common properties, the database is published on the internet. And after that, and data engineer make a detailed mapping to create generating RDF metadata. So not all databases in Japan search has this RDF metadata. But once this RDF metadata is created, you can use Sparkle to make accurate search. I will explain metadata mapping in detail because this is a very large difference between our system and other systems. Usually, I think in many systems, mapping means converting one field to another field, which is defined by metadata schema of the system. For example, in Europeana, they have EDM. So in that case, they must convert original metadata to EDM schema. For example, in this slide, the one database has title field, subject field, and also extent fields. And if the data aggregation system schema does not have extent field, these fields are usually mapping to other fields. So once mapping has finished, there are title and subject is converted to class, and extent becomes other field. So before conversion, extent, this 20 centimeters have the explicit meaning, but after the conversion, some meaning are lost because the schema does not have needed appropriate field for the original metadata. Also, this mapping is very difficult because someone might think subject is class or other field or some kind of that. So they made a lot of decision about the mapping. And also original data holders has always say something about their metadata expression. So usually sometimes they can't allow extent to become other field, but they demand creating another field. And so I experienced this kind of metadata mapping problem in my works. So in Japan search, we have more simple rules. Our converting rule is, our mapping is not convert rule. This is, how to say, this is copy rule. So original metadata, all original metadata is retained, but simple mapping will create a common field. For example, so title and subject and extent remains the same, but this is the title is name or title field this mapping rules shows title is name or title field. So a common field of name or title is created. And in display, we show common field, which is mapped, and also we show original field. So this mapping method makes the effort to join Japan search minimum. Minimum requirements are just ID and title and also a URL. So it is very easy to join Japan search. Also, we have metadata analyzer, which analyzes values of original fields and suggests which fields should be mapped to common fields. In contrast, RTF mapping needs more precise conversion and many decisions. So this is done by experienced data engineer. So consistency is guaranteed by him. Data provider has no say to this mapping. So mapping, yes. Okay, I'll demonstrate how to register metadata to Japan search. Can you see Excel file?
Yes,
Okay.
we can. Yeah.
This is sample file. So sorry for this is mainly Japanese because this is from our digital collection. This Excel file has ID field, title, author, year, and URL of the item. Also call number and IIIF URLs and image thumbnail URL of the books. If you have, once you have this kind of XLS files, you can register this to Japan search. This is this page is not translated, but this is a database management functionality of Japan search. You can register data with this, just upload the Excel file and register the files. Once the files are registered, this is automatically converted. Excel file is firstly converted to JSON, and after converted to JSON, this is analyzed and analysis is running. So after analyzation, you can define which field is common field. This interface is used for mapping. These upper fields are original metadata fields. So this shows sample values and how many entry is filled with these fields, and also unique number of the contents. Also, this ID title author comes from the header of the Excel files. So these are original data, original metadata field. And here is common field labels, which is, as I said, common field mapping. So we have 1, 2, 3, 4, almost 15 common labels that user can map. But mandatory field is just ID and title. And you see this ID and title is already guessed by our system. So this is already set to this. And also URL is also guessed, and thumbnail URL is also guessed. So this sample is very simple. So user do not have to do anything, but they just save the values and go to the next step. But if you want to change the field, you can change which field is. For example, English title is, for example, title, or last updated field is no candidate because there are no date fields. And if you like contents URL is image URL, or this kind of you can do this kind of mapping with this this page. And after you have changed the mapping, you just register data, and it takes almost, because this Excel file is all 300 records, it takes 1 minute or 2 minutes. And after that, items metadata are indexed on Elasticsearch using these level definitions. And then you can search the Excel data as shown on this. And you see the metadata details. This mapping is, title mapping field. And these are original fields. You see? So connecting to Japan Search is very easy and require only web UIs. Of course, there are many minor problems or need some conversion, and so actually there are a lot of minor problems. But basically it is very easy. And after you search, after you test the search result, you will publish the data. And then the data is open to public and also searchable through REST APIs. So this is also I have skipped the creating database phase. Creating database is just put the database ID or database name and also database URL or such kind of thing, and also select content rights of the database. And you need this form field to create the database. And also to log in the system, you must register organizations. So you need, this is a organization page of the MDL. You need to fill this form. So it's 7 minimum steps to register organization information, create database, and extract metadata from original systems with TSV or XLS, SX, and just register the data to the system. So, okay, I'll back to slides. As shown on the demonstrations, we have very limited common fields. For example, title and creator and location or temporal information. Meaningful, not systematic metadata, but also meaningful metadata is, I think, only title and person and place and time. Just that. So maybe some users are not satisfied with this search. So as we have very limited common fields, precise search is impossible. So, but most of users prefers Google-like search. So usually precise searching is not important, but we made a functionality to create more precise search form. Well, I'll explain this. Custom search, we call it custom search. Custom search is sort of predefinable search query to the Elasticsearch. If you want to search 2 kinds of database at once, you create search time mapping for the fields. As shown on search definition 2, if you define author field to search both database is author fields and database is name fields, you see So this database A has author field, and this database B has creator field. So in our system, these are indexed to different indexes, of course. So in general systems, in other systems, author and creator is mapped to same, for example, author field. So the user can search with author field only, but in our system, these are indexed to different fields. So we just use search time mapping to search both A.name and B.creator, and show in the GUI, we show this as single form. So user do not know this author field is actually searching A.name and B.creator in the background. So I'm sorry, I'm not sure I can explain clearly, but our intention is not do not make mapping on data incorporation, data import, but create mapping on search time. To help this, we have search designer. This is a with designer of the search query. Okay, I will show a quick example of that. This is search designer search design pages. At first, the search this search searches all the metadata in the system, but you can add the detailed field to search a limited field. For example, you just want to search, for example, I searched with the keyword author, and it shows the Mie Prefecture Art Museum Collections has a field called author, and also Cultural Heritage Online has a field named author, and so on and so on. So if you want to search all the field at once, you just select these fields and make this author. And then it shows just author field, but at the background, this actually searches these many fields, multiple fields of the each databases. So this is equivalent if you map when incorporate the database metadata to the system. How to say? You can do same thing on search phase, or you can do it on mapping phase. Both works, but our method is more flexible compared to mapping on import. Okay. We have Japan Search also implemented image search. You can select the image and you can search items with similar thumbnails. This image search is not tuned for the contents actually. So we just using ImageNet and mean average pooling layer from MobileNet to MobileNet V2 as feature vector. But this works pretty well. I'm not sure why, but mainly because these cultural heritage pictures are they are because they are pictures. I'm not sure, but this works very well. And our vector search is implemented on Baldo, which is Kubernetes-based distributed vector search engine developed by Yahoo Japan. One technique used is to combine vector search with Elasticsearch, because vector search is actually, how to say, not search, but kind of score sorting. So it is impossible to create facet with image search. So we took 1,000 similar images with top 1,000 similar images with vector search, and search again with IDs of these images on Elasticsearch. This enables faceting for image search, because use case of image search may include faceting with license. This is our another project. We call it Next Digital Library. I'll introduce because originally image search is implemented on this system. This service can search images from many public domain books, and such functionality is almost the same. But in this case, we extract images from book before indexing, which we use ESPNet, and which is a kind of semantic segmentation models. And next, and Japan Search has gallery functionality. Also, many digital archive systems has gallery pages or some similar similar pages, but our system is has very flexible editor also, and user can select predefined paths to create any page they like. And actually, for example, top pages of Japan Search is created using this gallery editor. So I will show you some gallery editor. This is pages of gallery editor. So we have text parts, image parts, list parts, and so on and so on. So if you want to insert text, select this, and you can write. And if you select the list, you can add the metadata to the list. My list. And you can add metadata and search by, for example, so. You can select them, and you can create the list with this. Also, you can edit the description, and also you can change the layout of the metadata, and so on. So you can create most of pages you imagine in digital archives with this editor. Okay. And this gallery editor is available as my note, which is shown on upper left pages. So, so user can, public user can use this gallery editor and create their own contents. But Japan Search is government domain site, so we don't allow users to make their works public, because some user might make fake gallery. So we do not allow, we can't allow publication by general users. But we have web parts functionality, which you can incorporate the gallery to your own website. web parts is actually snippet of JavaScript and which calls the API of the Japan search and creates the pages with these JavaScripts. So this is how web parts works. Once you create your gallery with MyNote and export web parts and paste it to your website. So this JavaScript snippets import the Japan search's JavaScript and also call the data API and then rendering gallery. Sample of this web parts is shown on this URL. But as far as I know, MyNote is difficult to most of the people. So I have created a more lightweight workspace. And workspace is collaborative gallery editor. If you can access to these URLs, please access the workspace. Okay, I'll test. It needs password to enter the room, but so in this workspace, you can enter with the workspace with this pencil button, and you can change, add data, and others can see this. Others can see the changes. This is a demonstration page, so you can edit this freely. So the workspace is a collaborating space to create the galleries, and which is used for currently experimentally used for schools teaching and also some library events for now. So workspace needs password to log in, and the contents of workspace is not published on Japan Search. This is some kind of isolated gallery space for specific purpose groups. And next is UI concepts. We aim simple UI concepts, but as I explained, Japan Search has a lot of functionality, so maybe it is not very easy to use. I don't know. I'm working for this product for a long time, so I can't say this is easy to understand or not. But as far as I know, many users do not know the all the functionality of Japan Search because we do not have time to enrich the help movies or help YouTube. We do not have time for that. Also, the most important UI element is license display. So for item pages, we show easy to understand license display. If you click the license icon, you see description of the license and one-click copy button for references. I think Japan Search is top runner in regards to showing license of the contents. Okay. So the final section is future of national platform for digital resources. So, well, I'm mainly engineer for this project, but many questions arises while developing Japan Search. Are we infrastructure or just one service contents in the vast web? Or Japan Search is for specialists or for generic users? Or how digital heritage can be important to non-specialists? And what is the role of the digital archives? I don't know what is the digital archive. I can't understand it precisely because digital library, especially digital library of articles and books for researchers, has established non-denial role because they are replacement of existing paper library. But digital archives, which focuses on cultural assets, is not reach to that position because they are not replacement because museum cannot switch to digital. Library switch to digital, but museum cannot because they must hold the content items. And also they are not replacement because users want to go to see cultural assets in person. So digital archives need additional costs and additional focuses. And the importance of national platform is also non-deniable, but it took very long time to actually it takes very long time to the value of the platform is explicit. So we have but for short period of time, what should we do? Is this okay that Japan Search is infrastructure which no one uses? I think it's nonsense because we cannot gather metadata without nice use cases. Because our fighting ground is vast free World Wide Web, so this is very hard fight, but we have some chances. One is education, because not every classroom can go to a museum. Also, it is important that license is clear to use with teaching. So the workspace functionality is used for this kind of experiment. And another is for designers, which will help with explicit licenses. These are major chances that we found. And future plan is familiarize the public with JPS because Japan Search is not so known to many Japanese or foreign people, and they expand the scope of cooperation for local digital resources. So, Japan Search has just started, but to be effective, it must be alive for a long time, I think. And while essentially we are infrastructure, we should keep up with modern web services, not to fade out. Just not to fade out. As such, we must face both experts and non-experts. Moreover, I think it is very important to bridge both of them. Also, as for system, we need stability in system, but also agility is very much needed. Recent technology made this more easier, I think. So we should be source of the information, but also a large content distributor in the web world, in the world of the web. Okay, thank you for listening.
Thank you for a very interesting talk. I think people have questions, but if those you have questions, you can type on chat window or Q&A window, and I can, or raise your hand. I can. Okay, I have a question. The question is how many developers are contributing? That's a very good question.
Yeah, my team consists of almost 3 to 5 people, and most of the Japan Search is developed by me, and front end is 80% of front end is written by me. And also we have designers. They write CSS and some components of the application, but most of the application is written by me.
Okay, so that's a very good question. You said that the stability or preservation is very important issue. But if you leave in the air, what happens?
In that case, I don't know, but because I'm in MDL and I do not want to leave this for now. So as long as
I know, but if
remaining,
in the case, just in the case.
Yeah, but you should know that all the web services face the same type of problem. If it's not a very big services, but many small services face the same problem because it costs very much to develop the modern web services to make this outsource the development of this kind of system.
Okay, thank you. Any other questions? That's a very interesting question. Yeah. Any other questions? I think this talk is quite interesting that because you explained the very detailed implementation and the decisions in the designing the system. So, okay, I got the question.
It's a very good question. The IIIF itself is very good, API, at least for image API, because image API is used to cut the part of the image with ease. So, some functionality of the some functionality of galleries utilize the IIIF API, but I don't know. Japan Search has IIIF utility because some connected databases have IIIF API. So in this case, we can show images with IIIF. I think it's a good thing, but I'm not sure how to say. IIIF, if you can see contents on Japan Search, they will not go to original digital archive site. If it's okay to original archive site, we are also okay. Well, actually, we are welcome because the presentation is concluded in only Japan Search. So this is my thoughts about use of IIIF. But I think IIIF is for other purposes, such as comparing images and such kind of thing. So that kind of usage is for experts only. So most of people, IIIF is irrelevant, I think.
Okay, thank you. Any other questions? Okay. I have a question. I think that it is interesting that you took a different approach from the Europeana in terms of the degree of the integration of the sources. So I think it is a trade-off between the cost to integrate them and I don't know how the integration level. And yes, there must be some good trade-off point. What do you think? Where is the best trade-off point?
Actually, I think there is no trade-off because in terms of search, you can define the custom search to do the same thing. But in very detailed levels, these indexes are separated. So, for example, sorting is not impossible with these fields because these fields are separated. So sorting with, in this case, a.author and a.b.name is impossible. So this might be trade-off, but it is usually irrelevant, I think. And also, if you search a lot of indexes at the same time, it might affect the performance. But in general, it is also neglect. It can be ignored, I think.
Okay, so you're saying that the complicated metadata is unnecessary.
Yes, in some sort. But yeah, if the users can agree with the complicated metadata, it is okay because users have same vocabulary to understand the data. So if the world is okay. So yeah.
Yeah, that's another question, but you
yes,
answer.
I will answer
yeah.
this question. Yes, of course. I think most of the search systems is dependent on Elasticsearch or Lucene in the background. But actually, these our system, of course, our system is heavily dependent on Elasticsearch. But if Elasticsearch is not maintained, I think there will be another kind of metadata search systems because search engine itself is a very essential part of the modern system development. So I think we can replace Elasticsearch to another systems. So I think.
Okay, so your system.
Yeah, my system is not so heavily, my system is currently heavily dependent on Elasticsearch, but it can be replaceable. For example, I can replace Elasticsearch with Solr.
Okay. I think there are a lot of questions in their mind, but we don't have not much time. I have just one quick question. What is the most accessed content so far?
I think it's a gallery page for Japanese sword, maybe. But wait a minute. Oh, PV page is not working. I think it's a gallery page on top or gallery pages of Japanese sword. So many users access to gallery pages.
Okay, thank you. And probably it's up. And please give a big hand to the speaker, Dr. Kawashima. And we want to close this session. Thank you for joining us, everybody.
Thank you for listening.
Thank you very much. And we move to the closing.